how to solve math problems in the simplest way. Of course, this applies to tasks that can be solved in multiple ways. Let's look at the assignment given to elementary school students in Japan. This is my reaction to a video explaining how to solve this problem. At the end of the video, I will explain why this type of task is manipulation. We can see how the task is set up in a Japanese school through this illustration, and how the task was set in the video.
We have a square with a side length of 8 centimeters. From one corner, construct a quarter circle with a radius of 8 centimeters, passing through 2 adjacent corners of the square. From the opposite corner, construct a similar quarter circle. We now have a region between the 2 quarter circles, and the problem is to solve for this area. What tripped up many adults is that they were trying to remember a specific formula for the area of such an almond-shaped region. And in fact, most students would not learn a special formula for the area of
the task is to find the shaded area, which we will mark as Area A task. The figure shows a square with sides equal to 8 units. We can also see a segment of 2 circles, Circle 1 and Circle 2. The radius of the circle is equal to the side of the square and is 8 units. We also have 2 areas that we will label them as A1. First, we will construct a square with a side of 8 units. We will also construct first of 2 circles whose radius is 8 units. We will also label the area A1. From the drawing, we can conclude that the side of the square that surrounds the circle is 16 units. So we construct a square with a side of 16 units around the circle. If we mark all areas A1, it turns out that the area of the square is equal to the area of the circle plus 4 areas A1. From here, we get that 4 area A1 is equal to the area of the square minus the area of the circle. The area of a square is 16 squared equals 256. The area of a circle is equal to r squared times p equals 200.96. 4A1 area equal to the area of the square minus the area of the circle. A1 is equal to 13.76. We can summarize the obtained results. The area of A square is equal to 256. Area A of the circle is equal to 200.96. Area A1 equal to 13.76. If we go back, where we started solving the problem, and construct another circle from our illustration, we will get the same geometric figure from the beginning of the video. We mark 2 area A1, and the area A task we are interested in. From here, the area of the square is equal to the area of the task plus 2 areas A1. The area of the A task equal to area of the square minus 2 areas A1. The area of the A square equal to 8 multiplied by 8 equals 64. The area of the A task is equal 64 minus 2 area A1. The area of the A task is equal 64 minus 27.52. Area of the A task is equal to 36.48. The way we solved it couldn't be simpler. But the way the problem was announced and resolved does not support the fact that the information was posted correctly. First, there is a rule for how geometric figures are labeled. For a triangle A, B, C, E, for a rectangle A, B, for a square just A, and for a circle the radius is given as R, or there is a written part of the task that provides the necessary information to solve the problem. If this is a square, why isn't it labeled correctly? Side A equals 8. Also, in the illustration, this side is not marked as radius R, meaning the side of the square does not have to be the radius of the circle. It is possible that we were solving a problem that was posed differently. For the solution we gave to be correct, 2 conditions are required. First, there must be a written comment in the problem that the radius of the circle is 8, which we do not have, or a comment that the sides of the square are tangents to the circle, which we also do not have confirmation of being present in the problem. In this case, we assume the radius is 8, but the person who made the video set the problem and solved it in their own way, and that's fine. I just solved the problem in a simpler and faster way. All problems like this have to be constructible, according to the theorems for circles and triangles. You can't just take circles, rectangles, squares, and randomly slap them on paper and expect something to be solved. My advice? Find and print out the theorems of circles and triangles, keep them close to you, and practice. Using the theorems, try to construct what you see, and with practice, you will very quickly be able to solve what you see correctly. You can't learn to ride a bike by just watching other kids do it, but with persistent practice, you can get there.